Hello everyone. This is Shivangi Baral, a sophomore year student, and I have been allotted sixth question of the third chapter. The readings given in the table in the next slide were recorded in a leveling operation from points 1 to 10. Reduce the levels by the height of instrument method and apply appropriate checks. The point 10 is a benchmark having elevation of 66.374 meter. Determine the loop closure and adjust the calculated values of the levels by applying necessary corrections. Also determine the mean gradient between the points 1 to 10. The table is given as follows along with station, chainage, backside, intermediate site, foresight, benchmarks and change point. Now let's go through some important terms related to the question. Station. A station is the point where the leveling staff is held. Height of instrument or height of collimation. For any setup of the level, the elevation of the line of sight is the height of instrument. Change point or turning point. A change point or turning point is the point where both the foresight and backsight are made on a staff held at that point. A change point is required before moving the level from one section to another section. By taking the foresight, the elevation of the change point is determined, and by taking the backside, the height of instrument is determined. Foresight. It is the last reading from an instrument position onto a staff held at a point. It is thus the last reading taken within a section of levels before shifting the instrument to the next section. Intermediate sight. The term intermediate sight covers all sightings and consequent staff readings made between backsight and foresight within each section. Thus, intermediate sight station is neither the change point nor the last point. Backsight. It is the first reading taken on the staff after setting up the level, usually to determine the height of instrument. It is usually made to some form of a benchmark or to the points whose elevation have already been determined. When the instrument position has to be changed, the first sight taken in the next section is also a backsight. A loop closure or misclosure is the amount by which a level circuit fails to close. It is the difference of elevation of the measured or computed elevation and known or established elevation of the same point. Thus, loop closure is given by E is equal to computed value of reduced level minus known value of reduced level. If the length of loop or circuit is L and the distance of a station to which the correction C is computed is I, then L is equal to minus EI by C. Alternatively, the correction is applied to the elevations of each change point and the closing point of known elevation. If there are n1 change points and the total number of points at which the correction are to be applied is n, is equal to n1 plus 1 and the correction at each point is minus e by n, the corrections at intermediate points are taken as the same as that for the change points to which they are related. Another approach could be to apply a total of minus e by 2 correction equally to all back sides and a total of plus e by 2 correction equally to all four sides. The readings given in the table in the next slide were recorded in a leveling operation from points 1 to 10. Reduce the levels by the height of instrument method and apply appropriate checks. The point 10 is a benchmark having elevation of 66.374 meter. Determine the loop closure and adjust the calculated values of the levels by applying necessary corrections. Also determine the mean gradient between the points 1 to 10. The table is given as follows along with station, chainage, backside, intermediate site, foresight, benchmarks and change point. These are the reduced level of points without omitting errors. Hence, at those points, reduced level is equal to previous height of instrument minus foresight, and current height of instrument is equal to reduced level plus backsight. For all other points, reduced level is equal to previous height of instrument minus intermediate sight. For loop closure and loop adjustment, the error at point 10 is equal to computed reduced level minus known reduced level, which is equal to 66.354 minus 66.374, which is equal to minus 0.020 meter. Therefore, the correction is 0.20 meter. Since there are 3 change points, there will be 4 instrument positions. Thus, the total number of points at which the corrections are to be applied is 4, that is, 3 change points and 1 last foresight. It is reasonable to assume that similar errors have occurred at each station, therefore, the correction for each instrument setting, which has to be applied progressively, is 0.020 divided by 4, which is 0.005 meter. These are the corrections for changing point. The corrections for intermediate sites will be same as the corrections for that instrument stations to which they are related. Therefore, correction for instrument site 3, 4 and 5 is 0.01 meter. Correction for instrument site 7 is 0.015 meter. Correction for instrument site 9 is 0.02 meter. Applying the above corrections to the respective reduced levels, the corrected reduced levels are obtained. The results have been presented in the table. Moving on to the gradient, the difference in level between points 1 and 10 is 66.324 minus 66.233, which is equal to minus 1.909 meter. The distance between points 1 and 10 is 180 meter. Therefore, gradient is equal to minus 0.1909 divided by 180, which is equal to minus 0.0106, which is equal to 1 in 94.3, and as the value is negative, it is falling. Thank you.